Okay, let's do addition and subtraction in polynomial. So add and subtract. Let's do an example. Say the first one, you have 5x to the third plus 2x to the square plus 4x plus 2x to the third minus 5x to the square plus 3x plus 4. Alright, so if you take a look at this example, you have this one polynomial added to another polynomial, and they are bounded by these parentheses. So when you add or subtract polynomial, you are going to combine what's called the like terms. So what is like term? Like term is the term that has same exponent, right? Same power of exponent. So let's see this term right here, 5x to the third. Like term would be this one right here, 2x to the third, because they both have x to the third. So these two are the like terms. Like terms. So when you add or subtract in the same sense, you can only combine the like terms together. So when you combine the number in front only. You have 5 and 2. When you add, that becomes 7, and that becomes x to the third. Just like that. Now you have plus 2x squared minus 5x squared. Of course, these two are also the like terms, right? So you combine plus 2, negative 5, and that becomes negative 3x to the square. Again, you combining plus 2, negative 5, that becomes negative 3. And you have 4x and 3x. These two are also the like terms, and you guessed it right, that becomes 7x. Now this one doesn't have the number term, and this one does. So what do? Well, number term, just carry it along. So this would be our final answer. All right. Now, subtraction works almost the same. Let's say we have 8x to the third minus 5x squared plus 7 minus 3x to the third plus 4x to the square minus 5x. Let's say we have something like this. Well, this polynomial subtraction works almost the same as polynomial addition. Only difference is that you are going to change everything. Those plus minus sign is going to be changed. Sign will change. So the first term is not going to change. It will be exactly same. 8x to the third, 5x to the square plus 7. But by applying this minus, right? By applying this minus, because of this minus, when we are getting rid of this parentheses, it'll change every single sign of the inside term. So now it's become, what used to be plus 3x to the third now become minus 3x to the third. What used to be the plus 4x squared now become minus 4x squared. What used to be minus 5x now become, remember because of this will change, become plus 5x, right? So because of this minus, inside term, every single sign will be flipped. All right, so now you just need to combine the like terms. Now let's see, this and this are the like terms. 8 minus 3, so that will be 5x to the third. Now negative 5x, negative 4x squared, right? Negative 5x squared, negative 4x squared. Combine negative 5, negative 4, negative 9x to the square. Now we could have wrote plus 7 here, but it's usually the case they write it in a nice descending order. So we have x to the third, x to the square. Now the x term, which is just 5x, and then plus 7, like that, right? So that's going to be polynomial subtraction, right? All right, let's do polynomial multiplication as well. Polynomial multiplication. So multiplying polynomial. Multiplication. Let's do an example. Let's say we have two polynomial, say 3x plus 1 multiplied to another polynomial 2x minus 3. Okay, so this first polynomial is going to be multiplied to this second polynomial. So in this case it's 2 terms by 2 terms, so we're going to do 2 times 2, 4 times of multiplication. So this term is going to be multiplied to this. This will be multiplied to this. This term is going to be multiplied to this. And that's going to be multiplied to this. So let's say this is the first, second, third, and fourth. So when you multiply 3x times 2x, now since this is 3x times 2x, let me actually write the whole thing. 3x times 2x. Now 3x, this was the first operation right there. Now 3x times negative 3. So you know the 3x, positive 3x times negative 3x, negative 3, so it'll be negative 3x times 3. Well, that might be confusing, so let me take it back. Let me rather do this. So it'll be 3x times negative 3. All right, so this would be the second operation. Now 1 times 2x is just 2x. This would be third. Right. Okay, this would be third right there. And 1 times negative 3x would be just negative 3. Okay. Now, what would be 3x times 2x? When you multiply these two, you multiply the number together, which is 6. And you have x times another x. X times another x would be x to the square, of course. Right? We have x times x, x squared. So 3x times negative 3 would be negative, because that's a positive 3 and this negative 3, 9x. So positive 3 times negative 3 becomes 9. And we have this x right there, so it's going to be there. And that didn't really change. 3. Just like that. Okay? So that's how you multiply these two polynomials. So another example. This time, let's say you have 2x minus 3, and you have x squared minus 3x plus 2. So this is the case that you have 2 terms times 3 terms. So there's 2 terms times 3 terms. How many actual multiplication that you have to do? You have to do 8 times. 6 times 2 by 3. Sorry, 6 times. So this will be multiplied to here. The first term is going to multiply to here. This will also be multiplied to here. The same way, this negative 3 will be multiplied to here, here, and here. So let's say this is the first, second, third, this will be fourth, fifth, and sixth operation, right? Okay, so 2x times x squared. Now let's take time. 2x times x squared. So it'll be 2. We have x times x squared. That's right. This would be x to the third. Right? And 2x times negative 3x. Let's multiply the number. 2 times negative 3, which is negative 6. So this would be the first term. 2 times negative 3 is negative 6. Now x times x, x squared. This is the second. 2x times 2, that would be plus 4x. This was the third. So we finished this top part. Now the bottom part right here. Negative 3 times x squared. So negative 3x squared. Negative 3 times negative 3x. Double negative becomes positive. So 9x. So this would be fourth. This would be fifth. Negative 3 times positive 2. Because that's right. This would be negative 6. And this would be our sixth term. Now, we are not quite done yet because we can still combine few things. If you take a look at this, a couple of these are the like terms. So which one of those are the like terms? You get it right. This and this, they both square terms, and this are the like terms, both x terms. So you can combine those two like terms, so it will be 2x to the cube, which you do not have like terms. These two are the like terms. You can combine the number, negative 6, negative 3, negative 9x squared, 4x plus 9x, which is 13x. And this one doesn't have like terms, negative 6. So this goes here. These two combined become this. These two combined becomes this. And that goes here. And that's our final answer. Right? That's how you multiply two polynomial terms. And polynomial division is also possible, and it's quite interesting. But before we do polynomial division, let's do a couple of special case for polynomial multiplication. Now, you can think of it as a formula, or you can think of it as just a simple trick of polynomial multiplication. There are a formula that's called difference of two square. So, difference of two square. Difference of two square. And it goes like this. X minus a times x plus a equal x squared minus a squared. Now that formula right there that you will use many times before you finish this course is called difference of two square. I want you to rather memorize this formula, right? Memorize this formula. But if you really take a look at this is nothing more than just simple multiplication. To verify this, you multiply x times x, which is x squared, x times a, which is plus ax, negative a times x, negative ax, negative a times positive a, negative a squared. So these two middle terms, the one's plus, one's minus, so they cancel each other. So you end up having x squared minus a squared, this, which is what it says in our formula. So the actual trick is, it doesn't really have to be x or the a. The point is that and that has to be the same. And that and that, the a has to be the same, and one has to be minus, one has to be plus, then this works. In other words, let's say you have b minus y and b plus y. Now, do we have same first term? Yes, we do. Do we have same second terms? Yes, we do. Do we have 1 minus and 1 plus? Yes, we do. Then what should be the answer? Whatever that we have in the first term, which is b squared, minus whatever that we have in the second term, which is y squared. So this formula can be applied like this. If I give you like extreme example, let's say we have moon plus star, and we have moon minus star. What should this be? Now, according to this formula right here, we have same first term, same second term, 1 plus, 1 minus. So this should be moon square minus star square, right? According to this formula, it becomes something like this. So, if we have like x minus 5, x plus 5, what should be the answer again? Well, the first term, which is x squared, minus second term, which is 5 squared. You can also rewrite this as x squared minus 25 if you want to. Right? If you leave it like that, I guess that's fine too. All right, so this formula right here, difference of 2 square. Very popular formula, right? Another formula that I like to mention is perfect square, right? Square of binomial or perfect square. Okay, perfect squares. Well, this formula goes something like this. Let's say you have x plus y square. Then this becomes x squared plus 2xy plus y squared. Right? So the first term square plus 2 times the first one, the second term, plus the second term square. Well, almost the same. If this is a minus in the middle, then it will be x squared minus 2xy plus y squared. So this formula is called perfect square formula. Again, another very, very popular formula I rather want you to memorize. They say math is not based on memory. Well, they lied. That's not really true. At least half of math, I'll say, is based on memory. You memorize the formula, you memorize the meaning of the symbol, you memorize the way to approach certain problems. And if you memorize certain things, it makes this certain math a whole lot easier. So I would recommend you to memorize this formula and also this formula. Okay. The last formula that I also like to introduce is what's called perfect cube. Perfect cubes. So this was perfect square. Let's do a perfect cube. It would be x. They usually use a here, so let's use a cube. This should be x squared plus 3 times ax squared plus 3 times a square x plus a to the cube. Another one, x minus a to the cube. Very similar to the first. Oh, sorry, this must be cube. Right, this must be cube. X to the cube minus a 3ax squared plus 3a squared x minus a to the cube. So this is another formula that you should definitely memorize. I mean, technically speaking, if you don't want to memorize this, you can write, for example, x a to the cube as x plus a, x plus a, and x plus a, and you do these two multiplications first, and then you also multiply to that to here to drive this formula, which will take a long time. So I would not recommend this. I would recommend you to rather memorize these 3 formulas, right? So this difference of 2 square, perfect square, and perfect cube. I rather want you to memorize this. Okay.